Students, welcome back to my exam success series. We are discussing today one more topic, a new topic, that is communication system. So we have divided this topic in two parts. That means we will have two videos on this. One is the first one and the next one will be the second part. So discussing about this, that is why this is important. We will go step by step in important points only. And finally, we will discuss about the MCQ part, the important questions which may come in the examination. So we will go to our first, what is communication? What is communication system? So definition, we should know, that is, what is communication system? So basic definition is a system that transfers information from one point to another point. Transferring of information. What are the key elements? That is, whatever that is to be transferred, that is source. Source can be sound, video, data. It has to be transmitted. It is converted to channels. That is the frequency band and everything. Then it is received, and finally the output, the input source, which has been sent, it has to be taken out from the destination part. These are the key elements of the communication. Why it is important? Enables global connectivity, information exchange, and technological advantage. These are the things. Without that, if we want to grow, it is very, very difficult. So communication plays a vital role for the growth of our subject or anything. Right. So please come to the right hand side. Here is a block diagram where transmitter, receiver, two sections have been sent. That is the instruments, you can say, information source encoded, channel encoder, then modulator, right? It is modulated. It is converted to channel, that is radio frequency or medium. We call it as a channel. Then it is coming to demodulate, detect or detector stage. Then decoder or channel decodation, source decode, and then information. So this chart is very, very important. This symbol on the left hand side is also important. Why? Because it will tell you we are discussing about communication, and that too wireless. Now on the right hand side down below, you can see satellite communication that we will discuss a little later. Uplink, downlink from Earth station and the satellite. All right. Now we will come to the historic evolution of different type of products for communication. First came the telegraph or Morse code, we call it as. That is short range burst signals, that is da, da, did. It was sent through codes. Okay, that is, we call it as a Morse code. It came in 1835. Then came the telephone, Graham Bell, that is 1876. You can see now we have gone to a long distance. Now we have come to smartphones. But remember, it started in 1876, the telephone system. Then we come to 1895, the radio. Radio was done by Marconi. That is a radio communication, different type of voices and listening to a long distance, right? That is a wireless mode communication. Okay, 1895. 1940s, television broadcasting came into existence. It was very beginning, starting of 1940s when television. Now we are into smartphones, that we get TV with the help of wireless as well as wired and different medium of communication. In 1970 came the digital communication. That was the big revolution, because before that we were all having analog communication. It's an old technology. Then came 1990 mobile communication. That was also a big revolution. That is, we started having handsets in our homes or in our hands for communication purpose. In 2000, the internet and wireless revolution has taken place. So here you have different type of revolution pictures. I have kept it. What are the different type of these things? I have given you a little idea about it. Okay, before that, before going into communication, very important part about this is we should understand the communication. And when we start communication, studying about communication, we should understand about heterodyne receivers, super heterodyne receivers. Now, this is a block diagram. You can see there is a first part. You can see on the top, there is an antenna. The antenna is connected to RF amplifier. Then it goes to mixer. Down below, there is a local oscillator. Local oscillations are produced. And finally, after mixing and local oscillation, we get a signal that is called as IF amplifier, intermediate frequency signals. Those signals are modulators, or it can be demodulated if it is a receiver side. It can be demodulated or modulated if it is a transmitter side, and it is converted to audio amplifier. This is a simple circuit of a radio receiver. We call it as a simple heterodyne receiver, mixing the incoming radio frequency, that is RF, Signal with a suitable local generated frequency from the local oscillator produce a constant lower intermediate frequency that is called as IF. This process is called as heterodyning. Okay, now we will discuss about the key components, that is information sources. Okay, so voice, data, video, sensor readings, these are information sources. I told you the 2 slides before that the diagram you have to remember the information source. Then the transmitter, what is transmitter? Modulates and amplifies signal. That is modem, RF transmitters. These are the transmitter which will have some power to send signal outside, right? So for information source, then comes the transmitter, then comes the channel. About channel, that is channel transmission medium, cable, fiber, air, water, in particular band or frequency. That is, we call it as a channel. Then comes the receiver part. That is very important part of your, or very important key component of your communication. Demonstrates and process signal. What it does, receiver demodulates, that is separation. Okay, modulation means mixing and demodulation means separating out the main signal from the radio frequency signal and the process signal. Then comes the destination part. Okay, end use or application. Speaker, if it is a sound, if it is a screen, it's a video, it has to be seen on the screen. Very important point in this, that is last point, it's called as noise. Okay, so what is noise? Unwanted interference, that is thermal, atmospheric, man-made. Any external electrical sort of, where you have little electricity in that, if it comes into your main signal, we call it as a noise. Okay, right. Now we'll come to the basic of signal type. So there are 2 basic type of signal, analog communication and you have a digital communication. Okay, so analog communication, it is a continuous signal. If somebody asks you what is analog communication, it's a continuous form of these signals, that is we call it analog. Examples of analog communication is your AM FM radios, analog TV, traditional telephone, the old type of traditional TVs and telephone systems. Simple, it is simple but susceptible to noise. That means the noise part plays a very important this thing in this. That is, more in analog, you will have more of a noise. Now comes the digital communication, that is discrete signals. Digital means discrete. So please remember this particular word, that is digital communication. It is there, it's a discrete signal. What is the example? Mobile phone, digital TV, internet, better, right? These are things. Better noise immunity, error correction. That is compared to analog. Here, better control or noise immunity corrections can be done. Okay. Now, come to the next part, that is the important part of it. Based on transmission mode. What are the transmission modes? Okay. What type of transmission modes we are discussing? One is called, first is called a simplex. That is one way. That is radio, TV, broadcast. Right? What is only one way? You can only watch, you can only listen. That is called as simplex. Then comes next one is half duplex, 2 ways, but not simultaneously. That is, you have to stop, then from other side they will speak. That means you are working on a single channel or a frequency. So both the side communication takes place on the same route. That is called as half duplex. Next is full duplex. That is simultaneous 2-way communication. At a time, both the channels will be working. That is transmission and receiving, both the things will be working. That is called as full duplex. All right, so let's go to the next part, that is medium of communication. See, please remember, I'm telling you what are important. I'm not discussing the complete chapter. We can go into the details of the chapter. I have so many videos on this particular subject, like mobile phone communication, other type of radio frequency communication, separate videos. If you want, you can just go and refer to my channel. But we are discussing for our preparation for our examination, what points are important for us. All right, so medium of communication, wired communication and wireless communication. What is wire? What we use? The main part is conducting material, that is called as copper wire, coaxial cable, fiber optics. These are the wire communication. A medium is there. Wireless, radio, microwave, satellite, infrared. That is through different medium, air and other mediums, we go through that medium. So wired and wireless. Then you have analog communication system. I told you the old type of analog communication system. In that we have used some modulation technique, that is mixing technique. One is AM, that is AM type of modulation, then FM, then PM. These are 3 main, that is modulation. Amplitude modulation, frequency modulation, and phase modulation. Now, in amplitude modulation, amplitude varies. That is the amplitude of the signal that varies. Application where you use medium wave, short wave radio broadcasting, low frequency radio broadcasting system. FM, that is information is frequency variation, right? Frequency variation will be there. Where we use it, application, where we do use, where we this thing, FM radio, audio, and TV. The noise will be a little lesser, the picture or video quality will be better. Then comes the phase modulation, that is PM. Information in phase variation, right? Phase will vary. That is application where we use it, some digital modulation, we use this. Okay, so these are the important points we are discussing. Now come to the digital communication. Now we are into digital era. So digital communication, you have to study more or you have to refer more. So what are the advantages? We'll discuss on the points. So the digital revolution advantages. It is good for our noise immunity compared to analogs. Regeneration possible, error detection, correction, CRC, Hamming codes, security wise, the encryption possible, multiplexing efficiency, that is TDMA better than the FDMA, the previous technology, that is time division multiple access is better than FDMA. Then integration pipe, that is, we are discussing about digital revolution advantages. Please remember, okay? Integration means voice, data, video, and convergence. These are the integration part of the digital system. Then in digital, what modulation we use, what techniques we use ASK, FSK, PSK, and ORM, right? That is QAM modulation. Now, what is ASK? Amplitude shift keying, FSK frequency shift keying, PSK phase shift keying, and QAM stands for quadrature amplitude modulation. So you can see here in the top, there is a picture here. I've given ASK, difference between ASK modulation, frequency shift, how the frequency shift will be taking place in ASK, how the amplitude shift will be taking place, and phase shift accordingly, right? So analog and digital little comparison is there, where AM, FM, and PM comes to analog, and rest of the things which comes to the digital part. So we can study more about this, that is analog and digital communication, mainly the digital communication. One more important topic we'll discuss, that is optical communication. So fiber optic system. What is fiber optic system? What are the main component of fiber optic system? That is the light source. Optics is a light. Fiber is a material. Light source, what light source? Laser or LED. That is this thing, through optical fiber, we send signal mixing with laser and LED light. Okay, so photo detector, that is PIN, APD, these are the photo detector. What are the advantages of fiber optics? Extremely high bandwidth. The bandwidth is very, very high compared to the analog, and the bandwidth is very, very good. TBPS, terabyte per seconds, the bandwidth. Okay, low attenuation, immune to EMI, small size, lightweight. These are the advantages. Where do we use it? What is the application? Internet backbone. It is internet backbone. Still, even today, we use fiber optics for internet connection. That is data transfer from one place to another place. Cable TV network, FTTH, fiber to home. That is we have called the FTTH. This and data centers we use it. Okay, these are the advantages. So here you can see I have given a simple example about the transmitter and the receiver part, how it is going, the light source is going through a cable medium, and how it is decoded again. So this is a simple example of that. Okay. Now we'll discuss one more important topic, that is the transmission medium. That is guided wire media, which will guide the transmission, right? So one is twisted pair wire type. We are discussing the medium, but hardware, the cables, we are discussing twisted pair, UTP, STP cables. So STP and UTP cables, you can see here in the picture. One is shielded, another one is non-shielded. So depending upon the application, we use or select different type of cables. These are the cables, very common cable, which is connected from computer to your monitor. So this is a coaxial type of a cable. It will be, or not coaxial exactly, some 16 wires will be there accordingly, right? So application, telephone, internet, CAT 5, 6, 7. These are the number, we call it as a CAT cables. CAT 5, 6, 7 coaxial cable, or another type of a cable. I said better shielding than twisted pair. Application, cable TV, broadcasting system, fiber optics. The other type of communication, because it has coaxial cable, mainly will have copper wire, shielded copper wire inside. Then comes the fiber optics, light transmission through glass fiber. This is very important. Fiber optics word comes, light transmission through glass fiber. Single mode, that is different type of mode of wires will be there. Long distance, high bandwidth. Multi-mode, short distance, lower cost. Please remember single mode and multi-mode. Application, backbone network, FTH, that is home to direct to your home. I just now we discussed, right? Unguided wireless media. The second point, unguided means radio waves, microwave, infrared, satellite. These are all unguided wireless system. So here, where we use it, radio waves, microwave, and infrared. Okay. Now, the MCQ on communication system, few questions are there. So question number 1, in a basic communication system, model the element that adds unwanted signal is called as noise. Please remember, it is not transmitter, receiver, channel, it is noise. Question number 2, which modulation technique varies the amplitude of the carrier according to the message signal? Amplitude is varied. That is AM, amplitude modulation we call it as. Question number 3, the process of converting analog signal to digital from forms involves what it involves? Sampling, quantization, and encoding. This is the correct answer. That is for question number 3. Now we'll go to question number 4. Which transmission medium provides the highest bandwidth and lowest attenuation? Fiber optics is the best. Okay, fiber optics, high bandwidth, just now we discussed, and attenuation is the lowest. Okay, question number 5. The time division multiple, that is TDMA, time division multiple access system. Multiple signals share the channel by using different frequency bands, using different time slots, using different codes, using different polarization. The correct answer is using different time slots. Okay, different time slots. You can send multiple signal, different channel in a single cable. All right, let's come to question number 6. The fiber optics communication. Single mode fibers are preferred for long distance, high bandwidth application. That's also just now we have discussed about this. Let's come to question number 7. In digital modulation, COM, that is digital modulation, QAM stands for what? Quadrature amplitude modulation is the correct answer. Let's come to question number 8. Which technology uses different spreading codes for multiple access? CDMA, code division multiple access system, right? Okay. Question number 9. The primary advantage of digital or analog communication is better noise immunity. So we have discussed 9 questions. We will have one more session on the same topic. We'll discuss more important topics and we'll take some important questions. I hope you liked it. If you liked it, please share with your friends and see you next time. Happy learning to all of you. Thanks for watching.